This video is on polymerization. Aims of this video are to know how addition polymers are formed from alkenes and to recognise the repeating unit in a polymer. So first we need to understand that polymerization or addition polymerization occurs when we have alkenes. And this is an alkene. It's a hydrocarbon with a double bond. Now it doesn't have to be a hydrocarbon to undergo addition polymerization. All it needs to have is this feature here, the double bond functional group. So we're going to put some groups around this CH3, CH3, doesn't matter what they are to be honest. And addition polymerization occurs when the double bond here breaks, and it will break when you use a catalyst, high pressure, high temperature. So this double bond breaks, and when the double bond breaks, where it ends up going is basically now these two carbons have a free bond in order to join onto others, and what it'll join onto is more of the same. And what you end up getting is a long chain of these monomers, is what we call the singular part. The monomers all join up to form polymers, and there will be repeating units, and so what you'll get is this CH3, CH3 on the top and HH on the bottom. So you get CH3, 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 all the way along. I'm not going to draw them all. And on the bottom you get H, 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 H. Now it's quite long-winded to draw this whole thing here. So what you can do instead is to draw brackets around the repeating unit. So the repeating unit is the following. You've got CH3 on the top, and you have H's on the bottom. Now you may say that actually just one of these is a repeating unit, but what you must do when you draw a repeating unit is base it on the alkene it came from, and an alkene must have at least 2 carbons in it. So you must make sure that your repeating unit is always 2 carbons long. So to recap, once I've just deleted these, what happens is that the double bond breaks. So first, double bond breaks, and then the monomer molecules join together, if you like. So how do you recognise a repeating unit in a polymer? We kind of covered this in the last slide, but we'll just go over it again. So imagine you have the following polymer structure. Sorry, I should have drawn this first, really, shouldn't I? You can clearly see that the repeating unit here is either this, or it is this. That's not, sorry. Or it is this here. So you've either got the F and F on the left-hand carbon or the FF on the right-hand carbon. And actually, it doesn't matter which one you choose as being the repeating unit. So that is repeating unit, and that where you draw it is the following. So either it's going to be this, or if you choose the other one, it's going to be this. Now if it asks for the repeating unit, there's no need to draw the brackets around it and all that. You can if you want, but there's no need to. If it asks for you to draw the polymer, then you will need to draw brackets around it and so on and put the N. But if it just asks for the repeating unit, all you need to draw is exactly that, as I did before. So here's an example question on this. So the first question says, alkenes can be polymerized to form polyalkenes. State the type of polymerization that alkenes undergo. So all of this that we've been doing in this video is known as addition polymerization. What's important that you do not write is additional. You have to just write addition polymerization. The second bit says, name the alkene that gives a polymer with the repeating unit shown below. So there's the polymer, or the repeating unit of the polymer rather. The alkene that would make this would be the alkene where there are no single bonds on either side and the double bond is reinstated. So this would be the alkene here. So you've got H, CH3, CH3, H. And we've now learnt that EZ isomerism occurs in alkenes, so you have to make sure that you include the E and the Z in the name, if you can do that. And here you can. You can see the methyl groups and the H groups are on opposite sides to each other. And so this is the E isomer. So the name of the alkene would be E, and then what it is. So you've got 4 in the longest chain, 1, 2, 3, 4. So it's bute, and the double bond starts on the second carbon. So it's E-bute 2-ene. As I said, the take-home point from this is that you must include, when you're naming alkenes now in Chem 2, if you can, you must include the E or the Z when you're naming them. I hope that helps with polymerization. Please let me know if you have any other questions you wish to ask.